Alright, so this is what you will do when you install your software, right? For me, I'm using Aspen 14 for this simulation. I'm using Aspen 14. So when you install your software and you open it, it takes some time to load. But if your computer is high-end PC, maybe Predator types and all of that, it will be easier. Typically, this I think this one I did last year for Anita, but it was incomplete. So this is your own here, this beta. Well, I don't know why it's taking some time, but it's supposed to be fast. Okay, so this is what you will have when you open it, when you open up the file and everything. This is the whole process. Yeah, the first step when you open a new file, what you have to do is you go to properties. You normally open up at the level of properties. There you go to components list. Here the component list you can add, but since I've already added this component list here, list number 1, and here I can double click on it to see the components that I'll be using in my simulation. I added methane, ethane, propane, iButane, N-butane, pentane, water, hydrogen sulfide, very important, nitrogen, oxygen, carbon monoxide, carbon dioxide, and thiophene. Thiophene is a heavy hydrocarbon. So with all these components I've added, so if I want to add, I just click here, then I take add, it moves this way. But since I've already added, there's no need. I'll do one with an empty chart and show you. The next thing is you choose your fluid package. The fluid package here I've already selected. You see the property package is Speng Robinson. Use this correlation when you're dealing with hydrocarbon systems. Use it when you're dealing with hydrocarbon, right? So use Speng Robinson. So if you double click on it, you can actually change it. You can maybe take Uniquark. You can use Uniquark, it's still good. You can use no, I think the best option here is either Uniquark or use Speng Robinson's, or you can also use NRTL. Like I said, it depends now on the particular chemicals or the composition of your fluid that is going into the process. If it's strictly hydrocarbon, Speng Robinson is the best. You can model for high temperatures and so on. NRTL2 is also good. It allows you to bring in other non-organic compounds, maybe like sulfur, nitrogen is Speng Robinson's, maybe things like sulfuric acid. Now if, for example, in our simulation here we needed to include a catalyst, because I've not used a catalyst, I don't know which particular catalyst you're supposed to use, but the equation that I'm using, it does not require a catalyst, so we're using Speng Robinson and it automatic here. Then you come to this reaction here, you click this here and you take set. Right now we have one reaction here. So this is important at the level of your reactor. I'll explain what the reactor is now. This is important at the level of your reactor. You put because the main thing that is reacting at that level is that thiophene. Is the heavy end hydrocarbons that are able to hold the sulfur compound. Because if you look at a C4 H10 I think it's S6, the chemical composition of thiophene. So this is where most of our sulfur in diesel and in crude oil is mostly found. After separating, maybe we are fractional distributing, most of the crude oil sulfur is in thiophene. for higher end hydrocarbons, but I think for color is based on what I'm having here. For color is diaphene. So you always set your stoichiometric coefficients to the reactants, right? The reactants are diaphene is reacting with hydrogen to give us hydrogen sulfide and N-butane. So for the reactants you put -1 -1, and the products you put 1 and 1. So if I put 1 and 1 here, let me just see, I have here -1 -1, I put 1 and I put 1 here. You see, I take enter. It's not balanced, so I need to come here and take balance. It balances everything for me, right? Then after you have set your reaction and your components and your fluid package, you come to simulation. Now at the level of simulation, this is where it becomes very complex. You always start little, then you take it, you start little, then you make it complex. So where am I going to start from? I'm going to start from the level of here. Now this all of this here, there's a lot going on, I understand, but what you need to understand here, you need to understand this home panel. This active means your simulator is going to be running as you're simulating. You don't want, with version 11 you have to manually run your simulation, even though you can activate that option here, but here you can automatically do it. It's already active. You need to understand this home panel here. Here you have capital. This is just calculating energy based on the cost. Each equipment you put here, the cost of the equipment moves up this way. So for this particular process is around 5 million USD, and you don't need anything here in economics, you know, except that you're doing economic evaluation. You don't need, yes, here in dynamics, this is where I can set it to manual, but I don't want it in manual. That's why I like 14. Calculate everything for you as you go. If you had live plants data, yes, here you can, but you don't need it. You don't need this. You need this. You know how to use your activation dashboard and model palette. Now your model palette is this here, where you have all your equipments like a mixer, tank, a 3-phase separator, expander, control, you can adjust, recycler, column, the types. So there are so many of them. It's a whole lesson on its own to understand how each one of them works. I mean, it's a whole lesson. So, and here you have your material stream, your energy stream, and your power stream. If the equipment requires power on its own, right? Even though Aspen can automatically calculate the power that each equipment requires, but here if you need energy stream, each component will definitely require an energy stream. Like for example, a pump needs energy, right? So your material stream is very important. The material stream is in blue, like this here. This diesel is in blue. This is a material stream. Now, so in order to run this simulation, let me make you understand it properly. You don't need much here. If it's in 14, this is where you'll be using a lot, but once you see a blue tick here, means the simulation is okay. So if it's in Aspen 11, you will need to use this panel a lot, but with 14 you don't need this panel so much. So the first thing is we need our diesel feed. We need to feed in the diesel that is coming in with the hydrogen, so the hydrogen sulfide and the sulfur components. Remember, we're trying to remove sulfur. So here, so basically the first thing I'll do is I come to the model palette and I click on this and I place it here, right? You see it's blue, meaning you have not done assign it to anything, it's just empty. Then I double click on it, I come to composition here, I take edit. Now if you, for your data, you always have a mole fraction of each composition, right? So, and you want a particular substance entering at a particular place. So for example, for our diesel feed, there's no need to put carbon dioxide in